Hi everyone, this is the third video of our Unit 3 review, and we're going to be talking about metals, nonmetals, and metalloids. So the first thing to note is that metals are all on the left side of the periodic table. So everything I'm highlighting in green is a metal. So all of these transition metals, the alkaline earth metals, and even some of these over here. Now notice that there is a purple staircase here, okay? And that staircase is what separates the metals from the nonmetals. So everything highlighted in green right now, all the lanthanide and actinide series, all of this is metals. So everything that I highlight in green, that is considered a metal. Okay, now our nonmetals, we're going to highlight those in blue. Okay, so those are right here. So all of our noble gases are nonmetals. Okay, all of our halogens are nonmetals. Okay, all of this nonmetals. The only one that I did forget about for just a moment is that we actually have a sneaky nonmetal over on the left side, and that would be hydrogen. And the reason why hydrogen is considered a nonmetal is because it's a gas at room temperature. So all of these blue ones are nonmetals. Now, there are some that are right along the staircase that are not highlighted, and those are called metalloids. They're kind of a mixture between metals and nonmetals. So if it's touching the staircase, okay, then it is considered a metalloid. So the elements that are in these boxes here are considered metalloids. The only exception to that is aluminum. Aluminum is indeed actually a metal, but the other ones, so boron, silicon, germanium, arsenic, antimony, beryllium, polonium, and astatine are all metalloids. Now, there are a couple that I did not kind of highlight underneath here. We've got some synthetic elements that are created, and they're not really classified as any of them. They don't exist naturally on the earth. They have to be created in a lab. And so this is where you can find each of those types. So for example, if I say, okay, well, what type of element is fluorine? You could say, well, fluorine is in the nonmetal section, or the fact that copper is a metal, or that even calcium, which is in our bones, is a metal, or potassium, or sodium, or nickel. Okay, these are all metals. You know, we've got gold and silver. Okay, these are all metals. Okay, and we've got nonmetals. So oxygen is a nonmetal, nitrogen, chlorine, bromine, neon, argon, helium, all of these are nonmetals. Okay, so you have to be able to decide whether it's a metal, nonmetal, or metalloid simply by its location on the periodic table. Now with that, okay, we can, with these three groupings, we can actually classify something as being a metal or a nonmetal simply by its chemical and physical properties. Okay, so all of these share similar things. Okay, so for example, metals have luster. Okay, that means they're shiny. Okay, nonmetals have no luster. Okay, that means they're not shiny or they're dull. Okay, metals are also malleable. Okay. Malleable means that it can be shaped into like flat pieces. You can hammer it. They are also ductile, meaning that they can be pulled into wires. However, nonmetals, if you were to attempt that, you would find out that nonmetals are brittle, meaning that they break easily if they're in their solid form. Okay. Metals tend to have higher melting points, higher melting and boiling points. So think about if you have gold versus oxygen. We know that oxygen at room temperature is a gas, whereas gold is a solid. So that means not only has oxygen already melted, it has also already boiled, and gold is not even close to melting yet. So that means nonmetals have lower melting and boiling points. So I'm going to just abbreviate that as melting point and boiling point. Okay. Metals tend to have a higher density, and nonmetals tend to have a lower density. Metals are good conductors of electricity, whereas nonmetals do not conduct electricity. Okay. We can also say that metals are almost all solids at room temperature. The only difference, or the only exception to that rule, is mercury, which is a liquid at room temperature. Okay, there are actually only 2 liquids on the entire periodic table at room temperature, and that's mercury and bromine. Nonmetals can be solids, liquids, or gases at room temperature. Or gases. Okay, so these are kind of your mostly physical properties. One chemical property to note is that metals are very reactive with acid. Okay, you normally see bubbling, things like that, but nonmetals do not react with acid. Okay, so if at any point you need to pause if you're writing this down, I know I write and talk faster maybe than you are at home. Remember, joy of a video is that you can rewind. The thing that we want to talk about with metalloids, okay, so a metalloid is going to have properties of both. Okay, so as an example, I want to describe to you silicon. Okay, silicon is the symbol Si, and it's right here on the periodic table. Okay, now silicon has a couple of properties. It's considered to be a semiconductor, which means it's good. It can conduct electricity, but it doesn't conduct a lot of it. So it's just a semiconductor. It's kind of conductive. It's shiny. It's a solid at room temperature. And it is also brittle. Okay. Now, the thing to keep in mind here is that shiny and solid at room temperature, that could be either a metal or a nonmetal. Shiny is always a property of a metal, and brittle is always a property of a nonmetal. So the fact that both exist in silicon makes it a metalloid. Okay, so you'll see just kind of a combination of properties in these metalloids. And so this is the basics of our metals, nonmetals, and metalloids.